Alright guys, so we're taking a look at some notes here, just adjusting everything for you. So looking at this, just some notes on graphing, kind of some basic graphing stuff here. So, and for some reason my tables didn't show up, so we'll just kind of make some up. Okay, it may look different if you have the actual notes, so which is okay. Good enough. Let's go -6, -2, +2, +6. Alright. Let's also go like this. We're able to fit more on this one. Actually, let's erase that. Let's make that -2, -1, 0, 1, and 2. And we'll make this 4, 1, -2, -5, -8. Alright, so with graphing, okay, just like with equations, we're still dealing with kind of where it starts and how it grows, right? Now generally, when we talk about start, we start calling it our y-intercept. Because we have the y-axis and we have the x-axis, right? These two number lines that together make that coordinate plane. And we need two of them because we usually have two variables, an input and an output is another term we often call them. But this idea that we're graphing two things at the same time, okay? So our start's our y-intercept, our growth is often called our slope, depending on the type of function we're dealing with. For us, the arithmetic and linear, we call it slope. When we get to the geometric or exponential, we kind of call it a factor or growth factor, kind of different, okay? Something else we need to understand is that we have two different types of graph or situations, discrete and continuous. A discrete one is one that's finite. It's not infinite, right? Whereas continuous would be infinite. Continuous keeps going. The dots are just to help you graph, and every line on the dot, well, I guess every point on that line is a solution to whatever equation or situation you're graphing. Whereas with discrete, it's only the dots that work, okay? So let me show you what I mean. So number one here would be discrete, okay? The reason being is we're using sequence notation. Generally with sequence notation, things are going to be discrete, okay? So I would graph 0, 6, -6 I should say, 1, -2, 2, +2, and 3, 6, okay? Now most of the time you guys would want to then, draw that line, okay? However, when we're dealing with discrete things, you don't, because that line means something, right? That line means that whatever situation we have, we've got an input and an output. Let's take it back to an equation, right? We've got, 3y = 5x + 1, whatever we have. But we've got those two variables, and these points are solutions to those two variables for an equation, okay? They're not just random points, they're solutions. And so when it's discrete, we only have these points we see, right? Nothing else, nothing in between, nothing beyond. That's all we've got, okay? That's what discrete is. And generally when we see this sequence notation, like 3 and 4, they're also going to be discrete, okay? Let's jump down and look at those ones real quick. Okay, so the idea here is that, right, we've got our a sub 0 equals -3, so that's like our 0 term, our starting term, our y-intercept. It would be the point 0, because that's what that means. That's our input, that's our term number, that's our output, that's our number in the sequence. So at 0, -3, we'd end up graphing it right there, okay? Then we're adding 4 each time. Okay, and what that means is that the sequence keeps, as sequence keeps going, we're adding 4 each time, right? So it'd be +1, Then we add another 4. It'd be positive 5, and so on. Okay, but what about the x value, the input value? Well, the idea is, when we think about a sequence, as we keep going, right, the previous number, the 0 term, plus 4 gives us the next term, or the first term. So it'd be 1, 1. Then it'd be the second term, 2, 5, and so on. Okay, and I suppose if you wanted to like draw an arrow like it keeps going, because we could keep it going if we really wanted to. But because it's recursive, we don't draw the dots. Okay, or we draw the dots, we don't draw the line. Okay, so like this, a sub 0 equals 5. So we'd start at 5. We're subtracting 2. So each time I go to the next term, the first term, from the 0 term, I'd subtract 2. So it'd be right here. Then I go to the second term, subtract 2. 3 minus 2 is 1. To the third term, subtract 2. It'd be negative 1. To the fourth term, subtract, not 1. Subtract 2, right? As we go to the fifth term, subtract 2, and so on. But again, we don't fill in the dots. It's all based off of just, not fill in the dots, that's the wrong word. We don't connect the dots, okay? Because it's not about connecting. It's about just these points that we have. Nothing is happening in between. The solutions are only these points, okay? That's all they are. They're only those points. If we look down at 5 and 6, we see the same thing, don't we? Still sequence notation, even though it's in the explicit form, right? The start plus or minus the growth times n. So that growth is still the same. The start also works the same, like if we make that table or those sequence. My start number is 4. And then what am I doing to it? Each new term, I'm subtracting 2. So second term gets to 0. Third term, negative 2, and so on. Okay, so I'd graph 0, 4. Then, again, as we go to the next term, I would go down 2. So we go 1 over to the second term, next term, down 2. To the next term, down, and so on. Okay, now there's another way we could kind of think about these ones, okay? Because they're kind of in that explicit format, and the explicit format allows us to kind of recognize the slope as the growth. So that negative 2n, we could think of it as negative 2 over 1, okay? And that slope tells us how we go from one point to the next point, okay? It's just a way to help us understand that. And the way it works is that the top number, that's our vertical change. Okay, so is it going up or down? Negative's down, positive is up. The number on the bottom, that's our horizontal change. Okay, how are we changing along the x-axis? Okay, and so, we often hear it called rise over run for the slope. We also could call it delta y over delta x. The deltas there mean the change in y over the change in x. Okay, those are kind of some ways we can think about it. But again, because it's not recursive, because it is that sequence format, we're not going to connect the dots. All right, same with 6. We'll start at negative 5. We think of that slope. If it doesn't have a 1 under it, it's like you put a 1 under it. So I'm going to go up 3 to the right 1. I'll add 3 every time we go to the next term. Okay, just like that. All right, and that's kind of what the discrete ones are looking like, because again, nothing's happening in between. That's the blank zone. There's nothing going on there. It's just these points that you have here. Okay. All right, now going back up to the top here, now we've got a table here where we've got the x and the y, don't we? Okay, which again correspond to the x-axis and the y-axis. And generally when we deal with graphing, we like to deal more with these kind of guys, okay? And most of the time when we see it, you could argue that tables are always going to be discrete because you don't know what's happening in between. But generally speaking, when we see the x and the y there, it's going to be continuous. So like we graph the points, right? Negative 2, 4. The x and then the y. Negative 2, positive 4. Okay. Then we graph negative 1, 1. So negative 1, 1. 0, negative 2. 0, negative 2. Okay, and I don't know why I'm drawing these extra little things. We don't really need them, right? 1, negative 5. So 1, negative 5, and then 2, negative 8, which would be down a bit further, somewhere right there. Okay, so when it's continuous, not only do we have the dots, but we draw the line representing every single dot.